Okay, so our second type of synovial joint is the hinge joint. And essentially in a hinge joint, we have a cylindrical piece on one bone that's fitting onto a kind of trough shape, or into, I should say, a trough shaped depression or surface on another bone. Okay, so it's called a hinge joint because it actually is very similar, to a hinge that you'd have on a door, a mechanical hinge. Okay, and the only types of movements that you get at a hinge are flexion and extension. Okay, so you can see the hinge joint here in the elbow between the trochlea of the humerus and the trochlear notch on the ulna. Okay, so this is really a beautiful hinge joint, one of my favorite in the body, because you get this beautiful hinge action. Okay, and so flexion, just to remind you what that means, flexion means that you are decreasing the angle of a joint. Okay, so we can think of the elbow in the anatomical position as being at 180 degrees. As we flex it, it goes to 90 degrees and then to a lower number. Okay, and then extension, we would be returning to the anatomical position or increasing the angle of the joint. Okay, so you can see that the two movements are opposite to each other. Okay, and we'll see when we get to the muscular system, we have one set of muscles that causes flexion, another set of muscles that causes extension at the elbow. Okay, now I've had a couple of questions about what the radius is doing as far as this joint. The radius is more along for the ride on this joint, or in this movement, than it is actually producing the movement. So we don't have really a hinge action between the radius and the capitulum. The hinge action really is between the trochlea and the trochlear notch. Okay, now that was a beautiful example of a hinge joint. Here's a less beautiful example, and that is the knee. Okay, and I'm not saying it's less beautiful because this model is in the state that it's in. Okay, it's less beautiful because of the bones that we're having fit together. Okay, now the knee is considered to be a modified hinge, and we do have somewhat of a trough-shaped depression on one bone and a cylindrical end of another bone, but not nearly as nice as we saw between the humerus and the ulna. Okay, so the condyles of the femur are essentially our cylindrical components, and the condyles of the tibia are essentially supposed to be our trough-shaped surfaces. But you can see that except for the addition of the plastic material, there really wouldn't be a good fit between these bones. Okay, you do get the flexion and extension at the knee joint, though, because of the hinge action that's possible there. Okay, so remember that flexion and extension are the only movements that can happen at a hinge joint, and just recall that flexion and extension are movements that are occurring in the sagittal plane. Okay, you might need to know that for future reference. Hint, hint.